Welcome to this talk. So my name is Frans. I'm the CTO of a company called New Orbit, and I'm going to talk just a little bit about the scaling resilience in the cloud 101, very much 101. So the thing is, can you all see my screen, by the way? Can I just check? That's all going good. Okay, so the thing is, you hear so much all the time about the right way to develop stuff in the cloud. And it's usually like, oh, well, you got to do what Netflix does. You got to do what Amazon does. You got to do this and that. And a lot of that is really good information. But a lot of that you really need to take with a pinch of salt. There are very few of us who get to develop systems at the scale of Netflix and the likes. So today, I'm going to, in James's word, I'm going to show you two weird tricks that is really the 101 for scale and resilience in the cloud. It's a starting point. It's something that you can do really easily on any cloud platform. I talk about Azure because I know it, but it applies pretty much the same to all of them. And it's something you can do without actually making massive changes to your existing code. These are the two things that, in my opinion, are the biggest immediate difference in mindset compared to the on-premise mindset, if you like. Now, I look at a lot of software that's already in the cloud for a lot of companies, and a lot of it still has this on-premise mindset. So just because your software is already in the cloud, that don't dismiss what I have to say. It might still apply. And I just want to stress, this isn't the end state. This is the start point. There's a ton more you can do. Just remember to actually look at what it is you need to achieve before you start building like another Netflix in order to support your blog site. All right. So what I'm talking about today are the things I say you should pretty much always do this, even for very simple things. They're not hard to do, and it really will help you. On the other hand, if you are about to build a system for millions of users, then you are on the wrong talk. Okay, just ignore me for the next 14 minutes or so. All right. So just the background to this, just to explain why I can sort of feel I can talk about this. So I've been building software in Azure since 2011 in my business, and some of them have been used by millions of people. Some of them have never seen more than 5 people. So we've covered the whole thing. And then for the last several years, we've also been an Azure Gold partner and reseller. And one of the things we do is we go into other companies, probably much like the ones that a lot of you guys work for, and look at how they use Azure and try and help them to save money, increase scale, improve security, that kind of stuff. So I get to see a lot of code. And what I'm basically talking about today are sort of the two core lessons that I have found that sort of make an immediate difference, but isn't that sort of a re-engineer everything kind of thing. So the first thing is just understanding the primary constraints. And this might be obvious to a lot of you, but to a lot of people I talk to, it really isn't, which is that scaling out in the cloud doesn't tend to work how people think. So if you have a web app with a few users and a web app and a database, people think I'll stick that in the cloud. And then when all of a sudden I get tons of users, then I just get more web servers and a bigger database, and it's all magic and everybody's happy and cheerful. That's not how it works unless you build your application to do this. The cloud will not do that for you on its own. What is more likely to happen if you just stick your code up there is that you get lots of users and you don't magically get another web server. Your website just breaks. And the user starts timing out. And then all of a sudden, 5-10 minutes later, oh, there you go, there's your new web servers. But now your database breaks because all of a sudden you're hammering with all of these requests. And then you fix that. And then sometimes later you get a bigger database. And then your site is up again. But you had all of this time when users were unhappy, the site broke, you lost data, you lost orders, and that kind of thing. And that's just how it works out of the box. The reason for that is really that is two things. Firstly, by default, when you're doing things like scaling, it's typically done on CPU. And CPU is not something you can measure at a point in time because web servers will hit 100% of CPU all the time. They're designed to do that. You can't just say, oh, if this web server hits 100%, you instantly spin up another server. You need to measure it over 5 or 10 minutes to know whether it's actually something sustained or just because our code takes all of the power it can. So there's just an inherent delay there. Now, you can use things like consumption plans and stuff that do auto scale based on number of requests. but they tend to cost a lot more for sustained throughput. So they're great for little small sites, but as soon as you start having a consistent level of traffic, they tend to be too expensive. Now, the second side is databases are a little bit harder. Again, some of them do have auto scale, elastic scale options, but again, you pay a lot more for them when you're like that. And when you don't have that, they can be slower to scale. A lot of the time it's fast. I have seen a scale operation on Azure taking 12 hours because sometimes you go over certain boundaries and then things just take a long time. Other times you need to bear in mind, if you scale up databases, sometimes you can't scale them down again. There are certain breakpoints, especially on Azure, where like certain things to secretly go over a certain thing, you can't get it below it again. Cosmos, you go up, you can never scale down to less than 100th. That's the maximum it has ever been. So there's a lot of things you can really get burned on with this kind of stuff. So the trick is to not just rely on this magic, but design your system to scale better. And there's sort of two things you can do here. The first one is queues, and you're going to hear a little bit about microservices in a bit, and Amir talked about them earlier. You can talk about microservices, distributed systems, this week's buzzword, but queues really should be in there. So if you take your website, this is how you would traditionally do a website. Let's say you have a thing where people can register for events. So you get a user here, he's going to go and do something and register for the event on your site. So that's your website. It calls out to some backend service. So let's say geolocation, just to get some information about where they live. And then you write it to the database. Now, the problem with this is it doesn't scale. If you do a marketing campaign and all of a sudden you get a lot of people trying to sign up here, what we saw before is it won't scale and you're going to have users timing out. If there's a bug in your code, so that if somebody puts in an address that looks a bit weird and you blow up, the user is going to see an error and you have lost the data. If that backend service you're talking to stops responding, it's likely that your code is going to blow up. You're going to report an error back and you're going to lose the data. If your database is overloaded, you got it, you lose the data. So what you should do instead, and this is really easy to do, it looks more complicated than it is. What you should do is when something happens in that the user, let's say again, register for an event, goes to the website, you can do simple reads and even simple writes to the database as long as they're not too dangerous to lose. But you should generally just post to a queue the thing you want the system to actually do something about. So you post a message to a queue. Now, Azure has apparently like 100 different ways of doing queues. The two main ones are service bus queues and storage queues. Storage queues are my go-to because Azure itself is built on top of storage queues. They're really dumb, really simple, but they are rock solid. In over a decade, I've only ever seen them be down for 2 hours in total about 6 years ago. So storage queues is my favorite, and service bus queues can do a ton more, but that also means you have to think about them more when you set them up. So what we then have is either a function or a web job, or if you're in Amazon, that would be a Lambda that reads from the queue. And what's nice about that is that one of the really nice things is they scale incredibly fast, because you can just say, rather than measuring load over time, you can just say, if there's more than 100 messages on this queue, start up another 2 servers, right? So it can scale in seconds. You can spin up more servers if you get a spike in traffic. And this thing over here doesn't really do anything. So that's very unlikely to ever get overloaded. All it does is it takes the payload and sticks it on the queue. And then this thing will call out to your service over here and it will write to the database. Now, what's nice about this is that if this service stops responding or you overload it, well, the message just goes back on the queue and it gets retried. Same thing with the database. If you have a bug in your code, it'll probably retry 10 times. It'll go on a poison queue. And then you just fix your codes, deploy the fix, replay the messages from the poison queue, and you haven't lost any data. I can't tell you how many times it has actually saved my bacon, that little thing, when there's been a dumb bug in some code. And we just haven't lost any data by just doing that. So that's queues. That's the first of my 2 weird tricks, as it were. So just use them. It took me, I once taught somebody to do the whole thing and set it up in Azure and wrote the code for this, 57 minutes end to end. less than an hour. I timed it. It really is that easy. No excuse not to do it. The second thing is about databases and thinking differently about databases. So traditionally, we are all very used to having one database, because if you're on premise, or even traditionally just think about, I need a database, I need a DBA, I need all of this kind of stuff. So you do everything in one database. In the cloud, it's really easy to have more than one kind of database. So I really think you should try and spread your load out and use different databases. So you can use a combination of SQL and Cosmos, for example, but in particular, back to storage, blob storage and table storage are really fantastic tools. They're incredibly scalable and incredibly cheap to run. So the point where table storage is so good that Microsoft is trying to hide it from you. I think in Amazon, the equivalent is Bigtable, and I'll give you an example of how to use that in a minute. So I like to call this a multimodal persistence model because it sounds really cool, but it just means using the right storage tool for the job. Right. So what does that mean in practice? I'll just give you. So again, we've built dozens of systems on this, but I'll give you an example of this particular system. Was for checking car history. So like for used cars, that whenever a used car dealer sells a car, then you need to do some checks on previous keepers, that kind of stuff. So in this scenario, talking about the multimodal persistence first, we had history on about 6 million cars, which was in Cosmos DB. And that would give us all of the history for a car in about 10 milliseconds. And that scales quite nicely. But in addition to that, I also needed 550 million mileage records on another 50 million cars. And you can imagine, so these 6 million cars cost me hundreds of pounds a month. And it has a limited scale because you can absolutely overload a Cosmos database. If you hit it hard, it will just start giving you 429 errors. So we stock them in table storage. That scales insanely well, and we actually can get the mileage history for a car in less than 4 milliseconds. And that cost me about 2 pints of beer a month. So it makes a lot of sense. Okay, so that's the first thing. So that's the example of using something like that. We do that a lot of the time. Again, table storage and blob storage are absolutely crap general purpose databases, but for the right kind of data, they are amazing and they scale exceedingly well. The second thing is queues. So this is a real example of queues here. So this particular system, it actually sits most of the time with just having a single web server with a single core on it, because the traffic isn't that high. And then, but once a day, they download an order file from a mainframe of all things with 1,000 orders and upload it into the system. Now, all we do on the front end is we take each line, each order, and write it into table storage, and we write each message out to a queue, again, to say, here's an order to process. So again, that happens literally in seconds from here, and then there's no real load on the front end. We then have functions picking that up, and they do a lot of work. They call back out to another mainframe to get data. They generate PDFs and send them out. They send requests over to some government agencies, the DVLA in the UK, and it writes to the database. And you can see, and because we are scaling up here, because we have a queue, within about 30 seconds of those orders being uploaded, we go from 1 server to 6 servers over here that are running this. Half an hour later, they scale back down to 1 server when they're done. So that's the kind of scale you get there with the queues. Now, of course, if you need to have millions of users, then you need a lot more than this, right? And then there's Kubernetes, Service Fabric, actor models, all of those very wonderful things, and they're great. They really are, and we use them when they're right. But as I said, for most systems, you probably don't need to go that far. Just start with some queues and some different databases. And that is really it. So I just wanted to say, I'm a bit of an Azure fanboy. I like talking about it. If you want to talk to somebody about, how to reduce cost, improve security, better scaling in Azure, just ping me an email or ping me on Twitter. we're not a consultancy as such. We're not going to try and sell you. I'm not going to try and sell you lots of consultancy hours. It's not our thing. We are an Azure reseller. So if you want to buy Azure from somebody who knows you're paying, that's really what we're interested in. But we're not going to sort of shove consultancy down your throat. But as I said, I just like talking about it. I'm an Azure geek. So with that, and very appropriately, Matt Hunt is here to talk to us about microservices.